turn to LED light source. Okay, so the on off switch is here, so you can get the LED light by simply pressing this on and off. Okay, now it's off. When it's solid, it is on. Okay, there's 3 wavelength, 3 LED here. One is the UV, the other one is blue, the third one is covering from green to yellow to red. So when you on all of this together, you will get a white light coming out. Okay, so just on, off. And one of the advantage of using LED is actually you can get instant on off. You don't have to wait. You know, in the previous one, the mercury burner, you have to wait 30 minutes before you can turn it on again, but this is instant on off. Okay, so on off button is here, and then the light will go through the filter set, which is mounted in this turret. Okay, so you have a DAPI filter set in position number 2, a FITC filter set in 3, and a PI, a TRITC in number 4. Okay, so that is for fluorescence imaging. Okay, and then moving down, you have the light path selector, which will distribute or channel the light all the way to the eyepiece or channel the light to the camera. Okay, so that is about the microscope hardware part, and then we'll move into the software. So the software itself, this is the software, Fluorescence standard. Double click to launch it. So I will start from the color imaging first. Those look for stain, color stain sample. So first things we do is always find the focus under 10x. So to get the live image, you just press this live button here. Okay, and then in this Fluorescence software, right, we have 2 layout. One is acquisition layout where you can do the image acquisition, and the other measurement layout is after image acquisition, when you want to do processing, measurement, then you come to this layout. So you start from the acquisition layout. On the left hand or the right hand side, okay, you get this camera control window. Okay, so here is where you can get a live image, live, and then if you want to do a movie recording, check this on. This will turn into movie button. Then you can start or stop movie from here. Okay, otherwise uncheck it. This will become snapshot. Okay, and then for live image, most of the time we will leave it to the automatic exposure time adjustment. Okay, you just let the software to decide what is the appropriate exposure time. Okay, if you don't like it, you can also change the exposure compensation. You can fine tune it. Let's say you think it is too bright, you can always apply a minus factor, then it will become dimmer and dimmer. If you apply a plus factor, it will become brighter and brighter. So this is to fine tune how the image appear under automatic exposure. Okay, of course you can do a manual exposure also, where you can input your own value or the own value or adjust the slides here, to get to adjust the exposure time. The longer the exposure time means that you've given the sensor chip longer time to acquire the signal, so the image will look brighter and brighter. When you reduce it, the sensor don't have sufficient time to collect the signal, then you will become dimmer and dimmer. Okay, and then we have this SFL button. This is actually what we know as a super fluorescence. So the purpose is to protect the sensor chip from running into oversaturation. Okay, because in those dim sample or low light condition, right, the exposure time tends to be very high, and it can subsequently cause the sensitivity of the camera to become lower and lower. So this features is to protect the camera from this kind of situation. They'll try to limit the exposure time to protect your sensor chip. And then sensitivity is referring to the digital gain actually of the camera. So if you put to the higher, your sample will look, your image will look brighter and brighter. Okay, but the problem is if you use a higher gain, you will see a lot of noise at the background. So reason is because when they do this digital gain, the software itself cannot differentiate where is the signal coming from the sample and what is the signal that coming from the noise. So they will amplify both. Then you will see high level of noise at the background. So that is the sensitivity. And then this is a resolution. We have a live movie resolution and snapshot resolution. Okay, so under resolution of this snapshot part column here, you see there's more selection, more option here. So pixel shift is a special mechanism that this camera can perform to enable you to acquire high resolution image. Okay, so for example, at this 4140 times 3095 pixel shift mechanism, you can actually get about 12 megapixel image. Okay, so basically they are shifting the sensor in the camera to acquire more area, more higher resolution than the static one. Okay, so if you want to do high resolution imaging, you can consider using this high resolution imaging with this pixel shift mechanism. Okay, but then this pixel shift mechanism or this high resolution imaging will only be effective under low mag observation or low mag imaging. The reason is because under low mag, right, the digital resolution is the limiting factor of the whole image. When you go to high mag, like 20, 40, 60, the optical resolution is the one that limit the image or the quality of the image itself. Okay, so then we have also this binning mode. Binning mode is a way to magnify or to amplify the signal. So a 2x2 binning mode means that they'll collect the neighboring 4 pixel, the signal from neighboring 4 pixel into one, and it will give you the signal that seems like boosted by 4 times. But the problem is you are sacrificing your resolution. So instead of this original resolution, you actually lose the resolution by 2/4. Okay, so that is binning. And then we have this something like crop. When you activate it, you will see this blue box. Okay, so you can say apply to live, then only that particular region will be captured. Okay, so that is just like a crop feature. So let's say instead of taking the full frame, okay, you're only interested in this particular part, then you can adjust the size, you can move it around, adjust the size, you can move it around. So when you click snapshot, then only this part will be acquired. Okay, so the advantage here is, first, the file size is reduced because you're only taking this part. Second, if you want to do a movie recording, the speed, the frame rate can be increased. So if you are not using it, just uncheck. Okay, and then image averaging is a way that can help to reduce the noise of the image. Okay, so just now I say that when you put to high sensitivity, the background noise seems to be high. Okay, this background noise seems to be high. So if you go to do image averaging of 5, then you will see this is with a lot of background noise. When you do an image averaging, the noise level will be reduced. Okay, so what happened here is, instead of taking one image, they are actually taking 5 images and then average it out. Okay, so the noise happen randomly, so they'll come and go. So out of the 5 frames, maybe at this particular pixel, they only come once, so it will be neutralized. So that is how the image averaging works.
So this one max can set to how many?
I don't know how many is the max, but no, the longer or the higher the value you give, the longer you need to acquire the image. So again, depends on, let's say if your fluorescence sample is prone to breach, then when you use too high, before you acquire the image, maybe the signal already breached off. So you need to be careful. So okay, then following the live image quality, when you put to the highest quality, the display itself looks nicer, but then also the response time or the frame refracting time will be slower because they need more time to process. Okay, and then the contrast. So if you have different stain sample, you can actually play around with this contrasting mode. Okay, so for live, for bright field imaging is quite straightforward. First things we do, white balance. Okay, so this is the button for white balance. So white balance on RI, click and then select the area that's supposed to be white, then they will do the white balancing, and then usually we'll put into automatic exposure time. Sensitivity will set to lowest so you can get best image quality, less noise. Okay, and then select the preferred resolution. Okay, then just acquire. So once you acquire, you'll see this is the acquired image with an asterisk star on the right hand corner. Okay, this means that the image is unsafe image. So to save the image, you just go to File, Save As, and then you can create a new folder, give a name, and then select the format. So there's a list of format. VSI is our own Olympus format. It can be viewed with ImageJ, with the Olympus viewer plugin also, VSI. Okay, TIFF is an open source format. Okay, so we will recommend you to save image in this VSI or TIFF mode, TIFF format, because only with these two you'll be able to reserve or preserve the metadata of the image. The metadata of the image is referred to when you go to this properties window. You can see there's a list of information here. What is the magnification that you use, what is the exposure time, the gain, the sensitivity, the resolution, things like that. So all of this information will be written together with the image if you save it in TIFF or VSI. If you save in JPEG, PNG and the rest, this information will lose. Okay, so if you want to do processing, measurement, it is very important to save the image in either VSI or TIFF.